Okay, fifth grade. Today we're going to combine two lessons. We're going to look at lesson 15, which is on page 101. And then we're going to do lesson 16, which is on page, I don't know, the next page. No, page 107. Okay, so let's take a look. Today we're going to look at line plots. Okay, so we're going to take a few little notes here because there's some steps that we need to do when creating a line plot. And a line plot is just another way to show data, to graph. You know, we can use bar graphs, we can use all kinds of different ways to show data, line graphs. And this is just another way. It's called a line plot. Okay, so up at the top here, I want us to put line plot. That is what we're going to be learning how to do today. And we have some steps we're going to follow. This is one of those things that can be tricky. I wouldn't say it's difficult, but if you don't do it systematically, you could do it wrong. So we want to kind of follow some steps. And there are many ways to create this number line, but I'm going to kind of share with you my steps that I use that you'll be using today. So my very first step, and I want you to write this, is we're going to identify. So identify the number range. Identify the number range. Okay, so let's look at the problem and what they've given us. It says Lacey raises mice. She measures the mass of each mice 3 weeks after its birth. Lacey records the data in a table. Okay, so here's the table, another way to record data. And we see that this data has a title. We can see her measurement, and she's measuring them in grams. Okay, so we're going to be using this information in this chart here, and we're going to be creating a line plot based on this information. Okay, so when I look at this, I first want to identify the number range. When I'm creating my number line, I need to know kind of what's the smallest number I'm going to put on the line and what is the greatest number that I'm going to put on the line. So I'm looking here, I'm looking mainly at my whole numbers. I see 7s and I see 6s, okay? So if I see 6 3/4, I know that my number line has to be a little bit smaller than that for this number to fit on there, right? So my smallest number is going to be a 6. So I would say that my range is going to be a 6 on the bottom end because I don't see any number that's smaller than a 6. I see 6 and like a fraction. And then I'm looking here and I see 7s, and I see 7s with a fraction. If I just make my number line go up to 7, I won't be able to put these on that number line, right? This goes beyond the whole number 7. So our range has to be bigger than 7. So we're going to go all the way up to 8. Does that make sense? So we need to have 6 through 7 on this number line. When we're doing a number line, we do our very best to spread things out and kind of do evenly. So you're going to see this little, you see down here, we have a 0 they've already put for us. You see how that arrow goes on because we know that numbers, there are still numbers below 0. Those are called negative integers or negative numbers, like a -6. And then on this side of the number line goes on and on and on because we have all our positive integers or positive numbers. The symbol that you see here just means that a section of the number line has been skipped. So we're going to skip like 0 to 5. We're going to start our number line at 6. So let's go ahead. Oh, I know what you're thinking. Don't say it. Here's a 6. Okay, we're going to go way down at this end of our number line, and you're going to have to write pretty small for this one today. I'm going to put a line, and I'm going to write my 8 down here, and then I'm going to try to get as careful as I can in the middle, and we are going to write a 7. Why did it have to be these numbers? Okay, so now let's look. We've got 6, we have 7, and we have 8. So that's our range, but we have to fit all of these parts of this have to be on our number line. So I'm looking at my denominator to see what my number line has to be broken into. I see eighths, I see fourths, and I see halves. And I can tell that all of these are related. I can change halves to fourths. I can also change it to eighths. I can change fourths to eighths, okay? So they're related units. And when I look at this number line, I think our easiest thing to look at and to see is we can think of these as halves and fourths. So let's go with our biggest unit first, which would be halves. Okay, so let's go down to our number line and let's think. So let's put that on identifying our range. Okay, 6.5. So let's go ahead and put our 6.5 on here. We're gonna have to write really small today, guys. So write really small. That's 6.5, not the most perfect half. Go over here. We're gonna write 7.5 on our number line. Okay, so now we're gonna go to our fourths. So if I'm thinking about fourths, right? I have fourths, so this is now halves. We're gonna make this into fourths. So if I make this into fourths, right, I have to have 4 equal parts. So let's think about this for a second. I'm gonna split these like this. Now I have 4 equal parts, 1, 2, 3, 4. This would be 6 1/4. This is already 6.5. This would be 6 3/4. 6.5 would be the same as 2/4. So 6 1/4, 6 2/4, 6 3/4. Then I come down here and I'm going to do the same thing here. I'm going to make my fourths. 7 1/4, 7 2/4, 7 3/4. Okay, writing really small, guys. Okay, because we're not done, we need to now break this into eighths because we have eighths up here. So if I go here, I'm going to kind of block out this and I think of my 6 up to my number 7, and I'm going to cut each of these pieces in half to make my eighths. Our eighths are our smallest pieces. Okay, so this would be 6 1/8. This would be 6 2/8, 6 3/8, 6 4/8, which is the same as 1/2, 6 5/8, 6 6/8, which is the same as this, and 6 7/8. Okay, so now listen, we could have converted all of these to eighths, but I feel like you need to understand how halves, fourths, and eighths relate to one another. Let's go over here. Okay, we've got our fourths and our halves. Now our eighths are going to cut all of these into pieces. Okay, and if you just count up and be real systematic and just make sure you know that these are fraction equivalents, right? So we have 7 1/8, 7 2/8, 7 3/8, 7 4/8, 7 5/8, 7 6/8, 7 7/8. Okay, so now we have all of our numbers on the line. Now, so we've identified our range, we've plotted our whole numbers and our fractions on the line, right? So I'm going to put our step 2 was plot the numbers. Sorry, let's change that to write the numbers. We're not plotting it yet. Write the numbers. And then we need to put a title on. So let's put title. So write the numbers and title. Sorry, change that on you. Okay, so we wrote the numbers. Let's give a title, okay? So our title is the same as up here. We have the masses of 3-week-old mice. So we're going to put up here, masses of 3-week-old mice. Okay, now down here, what do these measurements represent? Well, this is our actual measurement. So what do they represent? So they are telling the mass or the amount in grams. So let's label that. Okay, now we're at the stage where we are going to plot, okay? So we'll say we're going to plot data. That's our fourth step, plot data. And we're going to use X's. We're going to be systematic about how we're plotting our data, okay? So we're going to go up here and we're just going to go in order and we're going to use our X's for ours. So we have 7. So one mouse weighs 7 grams. Our next mouse is 7 3/8. So we have 7 3/8, crossing it off. 7 5/8, mark it, cross it off. 6 3/4, mark it, cross it off. 7 1/4, mark it, cross it off. 7 1/2, mark it, cross this off. 6 3/4. So you can see we have 2 mice that were that amount. Cross it off. 7 1/4. 2 mice that were that amount. 7 3/4. Mark it off. 7 1/4. 7 3/4. 7 3/8. Okay, so this is where we're going to have to be a little bit tricky. Let's see. What did you do? He's in there hiding. 7 3/8. Okay, so each of these X's stand for each of the mice. And then in lesson 16, we're going to talk about how to read this data and answer questions about it. We're not going to do that on this bottom page, so we're going to be skipping this part. Okay? All right. Let's go on to page 107, lesson 16. Now, they've done all the hard work for you because the hard work is really creating these line plots. So it says, Miss Song weighs the backpacks of all the students in her class. The line plot shows the weights of the backpack. So they've created it. So let's look and see what our range is because we're going to have to read some data and answer some questions about it. So the line plot is showing the weights of all the backpacks. Each of these X's would represent what? It would represent each student and the weight of their backpack, okay, in pounds. So now we're going to answer some questions using this actual line plot. How many students are in Miss Song's class? How do you know? So what would we do to find that out? We're going to count the X's, right? Because each X represents the students in her class, right? So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 students. Okay. How do we know? I know because I counted the X's on the line plot. Okay. What is the most frequent weight of the backpack? So the most frequent weight. So we're going to look here and we're going to say to ourselves, well, which one seems to be the greatest? It seems like 4 students have this weight. So the most frequent is 8 3/4 pounds because that's our measurement. What is the total weight of the 2 lightest backpacks. So sometimes they're going to actually have us do some math here. So we have 8 3/8 and 8 1/2. So 8 3/8, and I should be asking myself, not times, Mrs. Shaver. We're doing plus. Make yours a plus, not a times. 8 3/8 plus 8 1/2. So if I'm doing eighths, I should be able to, without, like in my head, changing that to eighths. So if I have 8 on the bottom, so here's my 8, and then on the bottom I have 8. What is half of 8? And you should say 4. And you're correct. Okay. So when we do that, we get 8 plus 8 is 16. 8 plus 3 is 7/8. Sorry, I don't know why I wrote 3. 7/8. Let's rewrite that over here. 16 7/8 pounds. Okay. What is the difference? So now we're going to put our subtraction to use, our work on fractions to use. What is the difference? So difference, subtraction, and weight between the heaviest and the lightest. Okay, this is where I'm going to actually leave the problem for you to solve on your own. It says 9 1/2 is our heaviest, minus 8 3/8. Okay, so there's my lightest, that's my heaviest. I'm going to let you do that one on your own. It's not too hard. You have to convert it. So come back to that one. Circle it. That's your one to do on your own. Ms. Song says that most of the backpacks weigh less than 9 pounds. Do you agree with her and why? So let's go back up to here. Here is the 9-pound mark. And she says most of them weigh less than 9 pounds. So is she correct? Yes. How do I know she's correct? Well, I can see that let's see how many of these are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 16 weigh less. We can use the chart to help us with that. So do we agree? Yes. Because 11 out of 16 weigh. Oops. WEIGH less than 9 pounds. Last question. Miss Song chose 2 backpacks that have a total of 18 pounds. Based on the data in the line plot, what could be the possible weight of each backpack? Okay, so this one is kind of a little challenge one. I want you to try it. Try to find 2 backpacks that when they add together, weigh 18 pounds. So we know 9 plus 9 is 18. So what fractions could be combined together to make 18? So it could 8 and an amount plus 9 and an amount equal 18. So see if you can figure out which 2 backpacks. There might be more than one right answer for this one. So this is a challenge. So what backpack plus this backpack could equal exactly 18 pounds? So we're looking for 2 weights that could equal 18 pounds. All right, finish off these 2 problems. Good luck.